This is section 5, definition of a derivative, example 3. So now that you know how to take a derivative, it's important to know when you can take a derivative because it doesn't always happen. Not everything is differentiable everywhere. And the only reason a function would not be differentiable at a certain location is if the curve is not, quote, smooth. All right? So there's two requirements in order to be differentiable. The first one is that the function must be continuous, okay? Which is why we spent so much time talking about continuity. It has to be continuous. If it's not continuous, then it's not differentiable at that particular location. That's not to say you can't take the derivative everywhere else. It just means that at that particular spot where it's not continuous, it is also not differentiable. The second requirement is that the function must be smooth, and this is a technical term, right? So because we need it to be smooth, something like the function to the right, where you have an absolute value function and it hits a corner at 3, it would not be differentiable at 3. Because in order to take a derivative, the tangent line has to exist. And we looked at tangent lines, and so we know that when one straight line approaches another straight line from the left and from the right, that tangent line in the middle where they meet doesn't exist. Because they're two opposing lines coming together. So they don't have the same tangent line. So if they don't have the same tangent line and that tangent line doesn't exist, you can't take the derivative there. Because the derivative is the slope of the tangent line. Tangent line doesn't exist, the derivative doesn't exist. Okay, now here are some definitions for differentiability. You can have differentiability at a point, differentiability on an interval, and a whole differentiable function. Okay, so some functions that are smooth everywhere would be differentiable everywhere. So what you have to worry about is what it's asking for. Okay, and there will be more examples of functions and finding differentiability. I need you to know, though, the biggest thing to focus on right now is that in order for a function to be differentiable, it must be smooth and continuous. Now, by looking at a graph, we need to be able to determine if it's differentiable and what the derivative is. And with linear functions, it's actually very easy. Okay, so we're just going to focus on that for now. When we get to more complicated functions, I'll have shown you some shortcuts to be able to do this. Okay, for now, we're just going to look at the slope of the tangent line. Now remember, tangent lines, if it's linear, are the line itself. You've seen that. Which means that in order to find the slope of the tangent line, if it's a linear function, you're really just finding the slope of that line. So if you look at example 3, this is supposed to be example 3, at -8, right? That's right here. Right here. It'd be great if my pen would work. So to find the slope of that line, it's just the slope of that line, rise over run. Rise is down 1, run is over 1, so that means it's -1. That's it. The slope. For -3, that happens right here. Well, the slope of that tangent line, if I were to draw a tangent line there, it would be horizontal. And the slope of a horizontal line is 0. 0, where x is 0, that's happening right here. Now remember, I told you, in order for the derivative to exist, you must have a smooth curve. And if you look at that, we have a semicircle running into a perfectly horizontal line. Okay, because one's not smoothly into the other, this derivative is not going to exist. For f prime of 1, well, 1 occurs right here. Okay, and that does have a slope. It's just not a very big slope, right? It's 0 because there's no rise. There's only a run. So that's 0. And then for f prime of 6, we have this point here. And so that rise is 1, up 1, over 2, so it'd be 1/2. Okay, now it's asking us to find all values where x where the derivative of f does not exist, and so that would occur where x equals, well, it's where you have any sharp corners. So that would happen at -6, 0, and 4. Because for all of those, one's not smoothly running into the other.